Our final year project is COVID-19 effects on risk minimizing portfolio for transportation and logistics assets using Mean-CVaR model. We were supervised by Sir Muhammad Azdi bin Maksar, and this is our group members.
I'm the group leader. My name is Salihuddin Ayub bin Jamal.
Hi, my name is Siti Zurani binti Abdullah.
Hi, my name is Nur Nadia binti Marasad.
First of all, I will present the introduction. Emergence of COVID-19 as a pandemic has affected the society's business institutions worldwide. Next, influencing the financial market. Modern portfolio theory is a Markowitz model used variance as a risk measure. Since that, optimization has been the center of work that concerns the decisions of the composition of the financial portfolios. The work done leads to mean risk models. Many risk measures have been introduced to optimize portfolio using mean risk models, such as LPM, MAD, VaR, and CVaR. In this study, we decide to use Mean-CVaR model to minimize the risk of portfolio. Next is problem statement. The focus of this research lies in finding the answers to the following questions. First, does Mean-CVaR model effective in minimizing the risk for portfolio of transportation and logistics assets? Second, which portfolio for transportation and logistics assets before and during COVID-19 has the higher risk in terms of CVaR as its risk measure? From this research question, we had set objectives that need to be achieved in this study. These study objectives are to minimize the risk of portfolio for transportation and logistics assets using Mean-CVaR model and to evaluate the difference between the risk behavior of portfolio for transportation and logistics assets before and during COVID-19 pandemic. Scope of project. Data of closing price were obtained from transportation and logistics assets which are listed in Bursa Malaysia. This study consists of 18 companies of transportation and logistics assets.
For the literature review, we will present the application of the Mean-CVaR model. One et al. In 2015 applied Mean-CVaR on a mixed portfolio consists of US timberland assets. They conclude that Mean-CVaR in a mixed portfolio reduced risk more effective than mean variance. Then, Zhao et al. In 2015 proposed Mean-CVaR skewness model on portfolio allocation of 19 constituent stocks. They conclude that the Mean-CVaR skewness model can be widely used to solve portfolio optimization problems. Chen and Wang in 2015 combined GNP and Mean-CVaR to construct portfolio and generate effective stock market strategies for investors. They claim that the proposed model could improve the efficiency of the traditional GNP. Next, Yu and Liu in 2021 develops a Mean-CVaR portfolio optimization model to determine the best personalized portfolio based on investors' risk tolerance. Next is the methodology. This is the flowchart of this study. Start with data collection, selection of model use, construction of in-sample portfolio, validation of the results using out-of-sample, and lastly, making conclusion. We proceed to the next page, which is data collection. The data of closing prices is obtained from data stream for 18 companies of transportation and logistic assets. The obtained data is simulated monthly for 18 stocks from December 2009 to December 2020. We simulated the data by using this equation. The scenario written has two parts of data, which is before and during COVID-19. Therefore, 130 scenarios are considered. Next is the selection of model use. Due to the shortcomings of VaR, we apply CVaR from Rockefeller and Uriasif in 2000. By minimize this equation, where the alpha is set at 0.05, V is stand for VaR of 5%, PI is equally probabilities, XJ is portfolio weight, where the summation of 18 weight is sum up to 1, and the weight must be between 0 and 1. Rij is the return of asset J under scenario I, where obtained from the simulated return Rm. This equation is used in the formulation of the Mean-CVaR model. This is the notation of the Mean-CVaR, followed by the condition that focus on the worst cases in the scenarios. Next is construction of in-sample portfolios. We construct 10 in-sample for B portfolios and D portfolios. B portfolios stand for before COVID-19 and D portfolios stand for during COVID-19. The 10 in-sample portfolios is constructed using the first 110 scenarios for in-sample 1 and the second 110 scenarios for in-sample 2. The process is repeated until we obtain the 10 in-sample portfolios using the rolling windows concept. We also specified the portfolio's construction at 3 level target return, which are low, medium, and high. The computation is set up in Microsoft Excel to optimize the portfolios. Then we analyze the risk behavior of B portfolios and D portfolios in the term of CVaR as risk measure to determine which portfolio has higher risk. Next is validation of result using out-of-sample analysis. We construct out-of-sample portfolios by using 130 scenarios. We calculated realized return to validate the portfolios constructed in the in-sample portfolios. We also compare the estimated and realized return from the out-of-sample analysis. Then we backtest the result obtained from the 10 in-sample portfolios to determine the consistency of the portfolio. Then we analyze the performance of B portfolios and D portfolios according to the realized return and the level of target returns. My friend Nadia will present for the next part, which is result and discussion.
Thank you, Zuraini. Proceed to result and discussion. By referring to the figure, it shows the comparison between B portfolios and D portfolios. B portfolios has lower risk value compared to D portfolios. Then, we conclude from the figure that the higher the target return, the higher the risk minimized for both portfolios. Next, the table represents the 5 in-sample for standard deviation and CVaR, where we can observe that standard deviation and CVaR for D portfolio is higher compared to B portfolio for all target return. Noted that the other 5 in-sample consists the same pattern where D portfolio has the higher risk for standard deviation and CVaR. Hence, we can say that during COVID-19 portfolios, that is D portfolio is more affected by COVID-19 pandemic. For backtesting, our sample portfolios is constructed using 130 scenarios from the set of data used in this research. Here is the realized return for in-sample 3 as reference. The results shown that D portfolios capture the higher return as the target return increase. The Mean-CVaR model minimize CVaR respectively. Hence, CVaR for B portfolio is lower for all target return. So, we can conclude that B portfolios outperform D portfolios for all target return in terms of CVaR as the risk measure. Finally, we make the comparison for CVaR 5% of B portfolio and CVaR 5% of D portfolios with equally-weighted portfolios. Equally-weighted portfolios means that invest capital is shared equally for all assets. Thus, as shown in the table, CVaR and standard deviation of B portfolios and D portfolios is compared with equally-weighted portfolios, that is EW portfolios. The results shown that EW portfolios have a higher risk than B portfolios and D portfolios. It was true because equally weighted portfolio did not minimize or maximize return when constructing it.
Next is conclusion. 2 main objectives were achieved in this study. For the first objective, we have minimized the risk of portfolio for transportation and logistics asset using Mean-CVaR model. As a result, Mean-CVaR optimal portfolio has lower risk compared to equally weighted portfolio. Then, we had evaluate the difference between the risk behavior of portfolio for transportation and logistics assets before and during COVID-19 pandemic. We found out that before COVID-19 has lower risk for all target levels than during COVID-19 in terms of CVaR as its risk measure. This study will be beneficial to society by providing a better understanding of the risk for transportation and logistics assets. Recommendations. First, investigate this study using other optimization models such as mean variance and mean absolute deviation to solve portfolio optimization problems. Second, focus on another category of assets, since transportation and logistics sector are not the only sector affected by the COVID-19.
That's all from us. Thank you very much for your time.